Alright, what's actually inside this thing. And yeah, that's a broken power bank I salvaged. Half of this robot is literally repurposed parts. Let me show you how it all fits together, because honestly, you probably have most of this stuff already. So this power bank shell broke, but the guts, totally fine. Look, here's the board with a charging circuit and two USB outputs. This one's 5 volts, 1 amp, powers the ESP32. This second output, 5 volts, 2 amps, that runs the PCA9685, that's the servo controller board. Now I soldered two 470 microfarad 10-volt capacitors right onto this cable to stabilize the power. Uh, Honestly, I'm not totally sure, but hey, no magic smoke yet. For movement, we've got four SG90 servos. These have been modified for continuous rotation, so they act like little motors driving the wheels. Pretty standard. Then there's this fifth SG90, unmodified, so it does 180 degrees. This one rotates the lidar sensor for scanning. 5 servos total, all running off that PC9685 controller because the ESP32 doesn't have enough PWM pins to handle this many. Now the chassis fully 3D printed. These boards have this grid of holes for M3 screws, so you can mount stuff wherever you want. Super modular. And check out the wheels, also 3D printed. But here's the trick. I cut rubber strips from an old bike tire inner tube and wrapped them around for grip. Works way better than plain plastic. You want traction, especially on smooth floors. For wiring, it's basically a ton of jumper wires and USB cables. The ESP32 connects to the PCA9685 via I2C, just two data lines plus power and ground. The lidar sensor, the VL53L0X, also runs on I2C. Same with the MPU6050, that's the IMU for tilt detection. Everything's daisy chained on the same I2C bus, which keeps wiring clean, well, cleaner than it could be. For sensors, here's the VL53L0X, the tiny laser rangefinder, accurate up to 2 meters, works great for obstacle detection. The MPU 6050 is the IMU accelerometer and gyroscope. Tells the rover if it's tilting or has crashed. And this is the ESP32, the brains of the operation. Handles all the sensors, motors, serves the web interface, and talks to my PC over Wi-Fi for the AI stuff.
So here's the ESP32 board.
Putting it all together is actually pretty straightforward. Mount the motors to the 3D printed chassis using M3 screws, attach the wheels, wire everything to the PCA 9685 and ESP32. Strap the power bank somewhere secure. Mount the lidar on a servo. Done. No special tools, no soldering iron if you buy pre-wired components. It's really just plug and screw.
So yeah, that's the hardware. Salvaged power bank, cheap servos, 3D printer parts, and ESP32, nothing fancy, nothing expensive, and it works. Next video I'll show you the firmware and how this thing actually talk to the AI. But for now, this is what an AI rover looks like and under the hood. Thank you. Please like, subscribe if you want more, and see ya.